Okay, we are recording now, I believe, or at least it indicates that. So welcome everybody. This is the May 14th review of the Object Bucket API, KEP. I'm going to be going over changes that we've made since the last meeting last week, and then I've got a couple more points on the agenda. At any moment, feel free to interject, ask questions, interrupt me. I'd like to have conversations as they evolve throughout the discussion here. So firstly, the most significant change that came out of the last meeting is a transition from a one-to-one model to a many-to-one design where we have many bucket objects that will connect to a single bucket content. So this is most pertinent in sharing of buckets. We feel that this more closely represents the actual life cycle of buckets and the way they're consumed. Buckets are generally accessed by many separate clients, or at least a handful, almost always more than one. So we felt that supporting that and streamlining that was one of the important parts of this API. Initially, we had thought that maybe we could manage this through bucket classes. Consensus was that this overloaded the purpose of the bucket class, and we agreed. And so we settled on bucket contents as being a user listable, user depending on permissions, maybe not readable, but at least viewable in terms of names, so that users can discover buckets that are, or rather bucket contents that are represented in the cluster at the time. So in this case here, this diagram depicts first a user creating a bucket. On the left-hand side here, the creator namespace creates the bucket. By referencing the bucket class, a bucket content object is created. The bucket gets provisioned, and then another user in another namespace can create a bucket in the same mode of, if you think of like PV to PVC static binding, the bucket will reference this bucket content by name, and through that, workloads can then access that backend storage endpoint. So yeah, go ahead.
And I'm sorry that, and this is Andrew. Yeah, so of course that opens up a huge number of questions that the doc in many cases just punts on, and so I suspect that you have answers to some of those, but didn't want to make them normative. But I'll just mention a couple, which is, how do I, as a user, when I'm requesting my first bucket, keep anybody else from accessing it, since I won't have presumably rights to the managing the content piece of it. And then there's all of the questions about how do we manage the life cycle of the bucket content if there are multiple references to it.
Right. So the first question we didn't really go over last week, and I haven't yet documented it because I wanted to pitch it to the group, so I'm glad you brought it up. In the case where I've created a bucket dynamic, or had created a bucket dynamically, I should not have write access to that bucket content, right? So our thinking has been, well, a field in the bucket object that is the originator of this bucket content should have a flag at a bare minimum of public private, such that I can say, okay, this is either public to the cluster or it's private and I only have access to it. This is reflected in something that we talked about last week and has since been added to the API. A list of, I've used the word bindable namespaces, that may not be the most descriptive, but a list of the namespaces that the cluster will use as a whitelist for namespace access, right? So if at a bare minimum, the originator should appear in this list, or the originator's namespace. And expanding on that, maybe something in the bucket could also allow other namespaces. I don't know if that's something we want to consider.
So again, I'm sorry, this is in the bucket content,
yes,
which doesn't exist in the dynamic provisioning case. So right? I mean, it doesn't exist yet. So you can't set policy for something that doesn't exist yet, unless you are suggesting what, that policy gets put in the bucket class and
I
then
am,
Right.
gets.
well, so I'm suggesting that my bucket API, and again, I haven't added it yet, but a parameter exist or a field exists in here in the mode of, this is either a private or public bucket as a Boolean.
Sure, but public
in
or
the case
private
of,
doesn't cover the range of what. So for example, I want it to be accessible by other applications in my namespace, but nobody else. So it's not private to this particular bucket claim, but it's private to this namespace. How do I articulate that desire as a user?
that is that's what I'm driving at with the sense of the public private, and so uh, that basically being exclusive to my namespace or inclusively
So
inclusive
private is not a one-to-one binding. Private is restrict access to the originating namespace.
Yes, and this is just to disambiguate a little bit, because this conversation or this topic blends separate layers of access, and there's a kind of a Kubernetes layer where we're controlling binding of API objects to other API objects, and then there's the lower layer where we're which we haven't quite touched on, and I don't think that's something we want to necessarily automate at the bucket level, and that is the object storage, ACLs, and access policies, right? So there's a difference between saying this is private to this set of credentials, because that's a object store layer access policy. And I don't think that at the moment anyway, we've really touched on how we want to handle that, or if we do.
I think, John, to add to what you're saying, that we wanted to have some exposure of this feature to the user, but most of it would be exposed, I guess, to an admin that can change it. So just like a network policies that you can set a nameless rule saying this namespace selectors can access me, for example. Right. So I think it's similar to what an admin would set for a namespace as a policy. The question is if the class should represent like the full capability of setting selectors, or something more to extend it to the user itself.
Actually, that's a good question, because one of the core aspects of object storage is that no one owns a bucket itself. It's more like which policy does this set of credentials have, which enables it to access certain objects or buckets. So in this diagram that you have on the screen right now, you point out that the secret it's being provided by the pod. So I don't know if this means that the application has to bring its own secret to being able to access stuff, or if that's going to be provided by COSI, because that also comes into place, that all this discussion that we're having regarding where is this policy going to be enforced as well.
Right,
yeah, and even if I may,
so
but
just
one...
let me touch on that real quick. So the
sure, yeah.
To your question of like, is the pod creating it or is it being brought in? Firstly, the solid lines here just represent references, not creation or ownership. And the expectation is that COSI and COSI automation will not mint credentials and will not create users, which is separate. So I am here, I'm trying to represent separately because we're not expecting to hand out credentials. In the brownfield case, there is room for, as you mentioned, the bucket policies that bridge credentials to buckets and define permissions, right?
Wait a minute.
So in the brownfield case,
that is a departure, right? So you're saying that now you don't think COSI should be minting access?
Yes, that's been something. Sorry, I know it's been a few meetings. The consensus has been up till now that COSI should be more concerned or exclusively concerned with bucket operations. And because IAM is a different interface, and there's many different implementations. of it between cloud services. And so we would effectively have to define a separate set of interface, or separate interface rather, for IAM operations and for bucket operations, which is something we could do, but at the outset for MVP, it doesn't seem like that's something we want to attack in concert
So
with.
that means then that this is not usable by itself. You have to implement some kind of out-of-band IAM management also then.
Or if you have credentials in the object store already, just create the secret with those credentials.
I have one question regarding this picture, maybe not this picture brownfield, but more dynamic. I'm more concerned that in the user namespace, we have a secret which refers to the cloud service IAM. And basically this secret allows users to create new buckets in cloud service. Seems like we allow users too much here, like to grant users permission to create new buckets is really like a lot, I guess.
Right, so I'm glad you brought that up. So there's a whole section down here on this, and we are, this is a kind of a brief or a paraphrasing of how secrets are kind of documented in CSI. And the way it breaks down is provisioners should have, if the secret's going to be used for the lifetime of that provisioner, or if it's going to have higher level privileges, that secret for the provisioner should be directly attached to the provisioner, share the namespace, not be available to users. If operations are per class, there are provisions for, again, similar to CSI, specific naming of a secret for that class to be used. And then as well as per bucket operations, leaving room for, if a user has permission to create buckets, they can provide the secret. Now we lean on the IAM policy here, because if that user provides a secret and that secret, the credentials don't have permission to create buckets, then they don't get a bucket, and we return an error, appropriately.
I'm still not 100% clear on this. Are you suggesting that if I want to dynamically, if I want to do a greenfield bucket class, if I want to do a greenfield bucket, that involves, I have to communicate credentials to the application that are going to access the resulting bucket. And I also need a set of credentials necessary for creating that resulting bucket. Right? So
yes.
Which set of credentials are you referring to, or are they the same?
Right, now that's a really good question, actually, because they can be different and they can be the same. I can have a set of credentials with permissions to create and audit and delete buckets. Separate set of credentials, only permission for a specific bucket, only allowed to read objects or even specific objects in that single bucket. So we're trying to.
I'm asking, is the pod? I mean, so there's two sets of credentials here. Logically, there's two sets. There's the set the provisioner uses, and then there's the set that the pod uses. I don't understand.
Right. So the secrets in this diagram are intended to be the pods accessing secrets for that bucket, not the provisioning or like administratively privileged secrets.
But I think we have a risk here that users will feel that if they're already creating and managing the buckets outside of the system to provide these secrets, they may not find value in using COSI for the rest. Right?
Yeah, I agree.
Right. And
you've taken the hard parts of the problem and taken them out of the problem.
True. It's also true that there are already IAM operators out there for cloud services and for some of the bring your own object stores. And depending
the goal,
on.
Oh, sorry. Go ahead.
No, go ahead.
Yeah. So I was just gonna say, it's true that there's operators that can create the credentials for you, but the purpose of this is to have cross compatibility. And so if we say that COSI can only create the bucket but not the credentials, then we're saying that we have cross compatibility for the data, for the storage, and then we have proprietary solutions for the permissions model. And so I kind of I agree, like if we can ensure compatibility, even if it's for a lower bar of services, like, you know, we don't support all of the internals of policies in our API, you know, some of those additional options can be, you know, defined in the bucket class to be specific to a provisioner. And so we can punt on some pieces of it, but I think that we have to have, or I would say, like, in order to be really useful, we have to have some cross compatibility for both credentials and buckets.
So what would that look like? I mean, I guess the idea was that we seem to be going down this rabbit hole with scope, and it was creeping. So the idea was for us to like pump the brakes, step back, and say, what is like minimal functionality for portability? That was the original intent of this, without being opinionated about AIM, because it isn't consistent from provider to provider. So if I guess I'd like to know people's opinions about, is there a common set that makes sense, that's minimal enough, or is it something
but the
that
protocol,
we do version 2?
but even the protocol itself, if we're going to the secrets, I mean, the protocol will also change the portability of solution, right? So you need to be portable within a protocol.
But if we so the where we were a couple weeks ago, and I apologize, I haven't been here for a while, but this has been a conflicting slot for me.
So all your fault, Andrew, just so you know.
Yeah.
Yes.
The thing, you know, where we were at one point was to say, look, we've got 3 sort of standard APIs here, and each of them expects to have handles to credentials in a particular way. Now, what those credentials can do or anything else, yes, could be handled with opaque parameters in the bucket class for the case where you're minting credentials. And so those could be passed through. And you have many more than 3 different IAM systems, unfortunately, right? There's a whole bunch of on-premise S3 compliant systems that have completely different user management approaches. But they by necessity, they all mint what looked like S3 credentials at the end for accessing. So the idea was that you could hide the details of what it would take to create a set of accesses around a bucket along with creating the bucket, and then just provide the credentials to that through this, so that you had one interface that gave you full access to the bucket. So now it's like you've got one that gives you access to the bucket, but you have to do an out-of-band provider-specific IAM access to it, which kind of means it's not even portable between all the S3 compliant ones. That's the concern.
I like the direction that this is actually going, with the separation of provisioning of bucket from minting, you know, IAM credentials and policy, because overloading all of that into a single API was getting very, very messy. But I also hear the feedback, which is not having a way to automate being able to mint identities and policy around that is going to leave this overall not very useful for end users. So I believe that there's a way that you can do that by adding to this model, right? So if you look at the way that it's currently structured, there is a secret used for accessing the bucket, and there is potentially a secret for provisioning the bucket. Who creates those secrets right now? We're saying, oh, it would be the end user, which we agree may not be ideal, but you could have another entity that provisions those secrets, right? So you could layer on an entire IAM system or something that automates the provisioning of those secrets in addition to what's being proposed here without changing anything here, or am I missing something?
So
that's right, Sam. We're trying to leave room for exactly that kind of automation.
So that automates provisioning of the secrets. It doesn't automate provisioning of the actual IAM components to it, right? That's my main concern is.
Yeah.
Oh, it can
but
be.
I think we can actually, because like you brought up a valid point that on-premise, there's different S3 providers that have different ways of managing access. So if we were on the thinking that each one of these providers will have to build their own COSI driver, then that means we can actually delegate the responsibility of managing access to the driver itself, right? So, and I don't think it will actually take away responsibility from the user, also a little responsibility from the administrator, and now it will put the pressure on the provider, on the driver builder to actually build a better integration for his solution, right? Because there's so many different solutions, and just like CSI, everyone who wants to play with CSI, they have to build their CSI driver, and then they take care of all these little nitty-gritty details.
Well, that was, yes, that was my vision, but I just don't see how that's doable with the affordances here. I don't know how they could implement this in a way that that secret can be provisioned.
And I feel like both, yeah. I'm fine if there, there's separate resources and separate controllers and maybe even separate provisioners. Like, that's all fine. But I do feel like it all has to be in cozy, because you don't gain any compatibility benefit if you have the data and not the access to it, both in the same set of standards. So like the implementation details of where these where these controllers live and what resources they're required, that totally open for all of that.
I think that's okay, as long as we're talking about a strictly separate set of APIs for minting credentials and identities and all of that from accessing the bucket. That seems okay to me. You can say it's part of cozy, sure, that's okay as well. But let's separate the minting of identity and credentials and policy separate from accessing the bucket and provisioning the bucket. And that way it just ends up with.
I do think there might be an intermediate here, but let me suggest the reason why I think that, so you've got identities, you've got roles or the equivalent, you've got access. And the problem is, depending on your system, that access may not be grantable until the object that you create exists, right? So you might want to mint credentials that only have access to the bucket that you're about to create. So it isn't that you can separately provision one and the other. You can provision the credentials after you provision the bucket, but that means then the credential provisioner has to be aware of the bucket. And that's the model.
That's okay, right? I mean, like in the Kubernetes.
That would be okay, but that argues they need to be in the same system, and they have to be some awareness that has to exist.
Okay, and that's okay. I
think
think
you want to apply IAM stuff as a separate stuff after bucket stuff. Sure, the separation of concerns, I agree, has some value and allows you to have different kinds of cardinalities in the relationships. But I'm worried by completely counting on it. It's just not a solvable problem.
Okay, I think we're in agreement there then. I think it makes sense as part of the same overall system, but just separated. Basically what Aaron was saying.
And then the question of, like, I feel like the question of, I've created a bucket, now can I mint credentials across it? Can I create a bucket content object across it? Those are similar requirements. It's like, can it be mounted here? Even though we're not mounting them, they're buckets. But can it be mounted to this namespace at all? And the question of, can I have credentials to it? So once I have exposed kind of this resource that exists, I can read and write to it. And I like the concept that I think John mentioned, that we would have a whitelist of namespaces, and maybe the default namespace that's always accessible is the originating namespace for that bucket, or something along those lines. Or maybe there isn't a default, and the customer always has to, the end user always has to enumerate which namespaces are available to create a bucket content within. But then you could also say, potentially, okay, here's a bucket and it's accessible to all of the namespaces, or here's a bucket and it's accessible to these specific. So it's like either there's a splat field in there, like in RBAC, or there's a enumerated list of namespaces. And we can use that same list for both the bucket content resources, which equate with like, amount and they also, we use that same list for, where can I mint credentials for these? Because you'll need to do both in order to access the bucket.
I like that idea.
I also have one very generic, if I may, one very generic. So at the time, again, like a couple of weeks back when I was at the meeting, there was no possibility for dynamic case to specify the bucket name. So now we changed that so we can specify specific bucket name we want to dynamically provision. Is that right?
Sorry, I'm not quite grokking the question there. Could you repeat that?
He's saying that it looked like, you and I had a discussion a while back about, should we be, for the greenfield case, should we provide explicit bucket name, or should we effectively leave that as a problem? You could specify prefix, but if you're minting a bucket, you can't guarantee bucket name. He's saying he thinks that he sees in here that you've reverted and there's back to providing explicit bucket. I think
right. So
no,
yes,
so
thank you,
yeah,
Andrew.
just to clarify, we don't yet. That was something we pulled out, and we only provide for a bucket prefix.
Okay.
And if the chart is leading to that, that leads me to another point about the names of these APIs. And we feel that calling this the bucket and this the bucket content has led to a lot of confusion. There's been comments in GitHub. There's been a lot of angst within our own team. So I do want to touch on that now. If we agree, one, that we need a separate API for credential provisioning, which it seems like we have consensus on there.
Yes.
Okay.
By separate API,
honestly,
can I just
go ahead.
Yeah, I wanted to just understand what you guys were suggesting with a separate API versus like an integrated API. So I understand that the desire for sort of an application attached bucket, right, which is being provisioned and the lifecycle is attached to the application, is something that is leading the greenfield case, right? So we make it like provision everything, like credentials and everything out of the box, and then that's great, but can't have another like entity saying like a bucket user or something like on those lines. Is that the
Yeah, that what I was actually suggesting is, imagine that we have two things, and the terminology we can deal with later, but there is a bucket and then there is a bucket access or something like that. And a bucket would be directly related to an underlying bucket. And a bucket access would represent a particular pod's access to a bucket. And so if you wanted a greenfield case, you would need a two-step. You would need to provision the bucket and you'd need to provision the access to it. But if it's in the brownfield case, all you would need to do is provision access to an existing bucket. And so, yeah, it would suggest that bucket is not the thing that a pod has. The pod has a bucket accessor, bucket, interface or something like that. And then the actual bucket is the thing that is dealt with just by the provisioner, by the bucket provisioner, as opposed to the access provisioner, which would be a separate thing.
So I really think this is a key thing in terminology, and I think John will also be interested to propose here, which sort of highlights where's the lines cross between bucket and the cluster scope, bucket content, and what does each one do, right? And we're trying to put some roles on them, and so the bucket is sort of the intention of the namespace to use a certain bucket resource, right? The bucket content is sort of the response that by the cluster saying that's the resource you should use, or I'm referring to binding to an existing one. But the access point here is like taking some piece of that, of the intention to use something or vision it, and mixing it with also the request for mounting credentials, right? So we need to sort of figure out how do we split it.
Yeah. So the model that I would kind of like to see, and I want to explain kind of what, this actually fixes some sins created in Service Catalog that I've lived through. because so the model that I think would be good here would be similar to roles, role bindings, and resources in the Kubernetes RBAC and users. So you would, I would see you could create a set of credentials. We call that whatever we want, object users or credential set or something along those lines. And then the bucket content, could be, it can do a little bit dual role. This bucket is mountable, and maybe also it is a binding between a bucket and a credential, or maybe those two things are separate. The reason why I kind of, or one of the things that we saw with Service Catalog is in Service Catalog, we kind of conflated a binding together with the credential set. And so that meant that anytime you removed a binding, you also removed a credential set. And when you rebound it, you rebound with a different credential set, which leads to all kinds of like ACL thrashing or bucket policy thrashing potentially on the user side, where you have to go re-permission or reapply bucket policies on the buckets. And so if we do create like a credential set controller of some sort, then you would bind those credentials independently to buckets, and you could unbind and rebind them, maybe with different bucket level permissions or a different bucket policy, in your implementation, whatever that looks like. And but the user could stay kind of persistently rather than having to be a function of some other binding.
Yeah, I agree. I think this is a good point in detaching the credential allocation from the intention to use a bucket. Right? So they might go together in many cases, but they might not as well.
But, yeah.
We just need to think if we want to have some flag that automates creation of the credential request as well, just by creating a bucket, for example, so that it's one less YAML to create.
I think that comment about the credential trashing, generating a lot of credentials with the identity management brought a very important point. That is a little bit going into security. If all the applications are sharing the same set of credentials, and each application might be vulnerable at different levels, right? That means I don't know if these credentials that are going to be seeded are going to have a wider scope of access, or if we're still going to be relying on users creating like specific per application credentials, right? But if we were to automate this, we will actually have to argue in favor of creating credentials that are scoped only for the accessing needs of this application, and not resharing repurposing the same credentials that are going all over the place, right? So that goes into like, yes, we will definitely need to generate a lot of credentials on the identity management software.
Yeah, if I can, I'm going to try to repeat back what I thought I heard you say and see if you think I caught the gist. The problem with sort of what I heard is the earlier suggestion is, rather than thinking about access to a bucket as something that you mint every time, you think of access to a bucket, i.e. the credentials for accessing the bucket, as having its own identity. And then there is a binding process that gives a particular pod the access to that. And that implies a desire to be able to reuse a set of credentials for accessing the bucket, yet that flies in the face of generally good security approach, where you really do want uniquely minted access for every pod that's going to access something, so that you can revoke credentials and only impact the scope of the particular thing that you're trying to revoke.
But let me ask, why not per namespace? Why per bucket?
Well, in a single namespace, you may have multiple applications, I would think. But I mean, if we were to use the application, and when I say application, it could be the pod, the deployment, the stateful set that's using this as the identity of the thing requesting access, and then we type that access to that application identity. We could actually solve this problem rather than, again,
So
sharing
we
some places across the
suggested with the service account initially, but wasn't really something very coherent, I guess, in the design. But we did look for some natural entity that represents I want to be sort of an account or represent an identity within Kubernetes, and service account was the only one we annotate for maybe requesting credentials, something like that.
So are you suggesting that this should use a model where the service account that the pod is running under should be the thing that is bound to the set of access credentials?
Yeah, service account represents the identity for pods, right? And for Kubernetes internal services, right? So this is sort of
as opposed to a separate resource that is providing that. You're saying the service account has a longer term life cycle maybe, and so you can set up access policies on that, and then pods can come and go and you should be okay, not have to churn.
Right, and if you need more than credential, it's okay as well if that's your model for creating more accounts, right? So I think we did talk about it initially. I don't know I don't remember the exact pushback, but there was a pushback that it shouldn't leak outside. But I think the point that we're talking about right now is it's not leaking it's not really representing an internal service account externally specifically. It's not what Cozy is about to do. We're just allowing the bind of credentials to come through a natural way from the service account rather than from something called a bucket, right? The bucket may still need to be mounted like a volume, but giving Cozy credentials to a pod is like, sort of using service account of that pod. So we can annotate, like, we can take the service account, annotate it for Cozy credentials, and Cozy can provide credentials for that for the pods that use that.
Yeah, I guess it's still not clear to me if we will have to have the administrator then having somehow attaching these credentials to a service account. Like if we were to look at solving the problem from service accounts, that would be, I mean, then along with managing service accounts, which is probably like already like a common thing on for administrators, they will have to additionally attach these service accounts some access, some Cozy kind of like annotation to indicate that there's some credentials that are seated for pods under the service account, right?
Right. Maybe annotation, Cozy annotation on the service account would just signal that.
Yeah, to some extent it's fair, because if it's already like common practice to do service accounts to scope the access an application has on your cluster, and that's like a really good security practice, then that's also the place where an administrator could bind some credentials, and then it gets the administrator thinking about what are the access needs for these credentials, but that he needs to ensure that those credentials have, right? So if he says this is a service account for 2 applications, I need to ensure that those 2 applications which have 4 buckets, the credentials have access to those 4 buckets and such.
Right, and also I think that this opens up a similar model of RBAC for buckets to be evolved around service accounts, and just it can be RBAC can also refer to other things, I guess, but anyway.
Yeah, I guess the one thing that I have to see the model. So this makes sense for providing, for saying this particular service account has access to a predefined set of detailed access policies. So there's another entity that still has to be provisioned and created there, and then we can separately deal with, okay, once we provision this other entity, how does a pod get to it? right? But that other entity, I think, still needs a driver for provisioning it. Some kind of way of saying, hey, I want a write-only access to this particular bucket, and you know, under the following kinds of conditions or something.
Does this entity need to know the pod? Like what kind of pod is that? Which pod is that? So it knows the service account?
I think so. I think that's the point, is that then if you have those entities as sort of first class things that are independent of how they are used, then you have a separate thing that binds them in, right? A separate thing, and that's what's not super clear. I understand the desire to do service accounts, but I think you still need something a controller can operate against to figure out it needs to provision secrets to the pod. That's
right. And it,
Right.
yeah,
It doesn't
terms
solve
of,
any problem. It's just a natural, maybe just a natural identity. You can certainly create a bucket secret account or a bucket user for that matter. But the question is, the question I think was originally, why do we need another at all, right? So the service account doesn't solve that. You still need to annotate it, so it doesn't really change the fact that you need something more than just creating your intention to get a bucket and credentials, right?
Or yeah, I guess the question is, how many annotations do we need on the service account in order to mint credentials, right? Because if it's 3, then it's too many, and so we should have a CRD for it. And if it's 2, like the way that load balancers get annotated or ingresses get annotated, then maybe that's enough.
I think it's mostly the bucket class, right? It's just like for bucket provisioning, and perhaps like additional, sort of a blob for, I don't know if blob probably doesn't make sense there, but
maybe there is just an annotation that says this service account is attached to this. Well, I don't know, but
that annotation could be on the bucket class itself, or whatever we're restricting access. That way you don't need annotations on service account. There was an interesting point where we're asking about how many fields need to be added, because the protocols may have different requirements, right? If we think about the S3 protocol, we only need like endpoint, bucket name, access, and secret. But if we're talking about GCS, GCS likes to use that service account file, a JSON file that needs to be mounted on the application. So that needs to be exposed somehow, and that kind of pushes us back to how are we going to deliver that information to the pod.
So can I try to summarize where we think we are right now? I think it sounds to me like the proposal currently focuses only on provisioning and accessing the bucket independent of ACLs and IAM. And I think the feedback has been a complete design cannot exclude those things. So we need to figure out how to incorporate those into the design. And I think from what I've seen, it sounds like we can probably add in additional APIs at the CAUSE layer, as well as potentially new Kubernetes objects to assist in provisioning IAM and ACLs. What that would look like remains to be determined. And the key question will be, how will it integrate with this design once we figure that out? And there seems to be kind of another question around, well, IAM and ACLs for any given storage backend are going to be different from storage system to storage system. Kubernetes has its own ACL system. Is there a way that we could find to map those somehow? And that seems like a challenge. People are talking about using a Kubernetes pod service account and potentially finding a way to map that. This sounds like a larger discussion, but does it summarize where we are? It points us at a kind of problem that we need to solve.
Yeah, I think that's accurate. Well, I think.
Yeah, I'd concur with that.
So can we say as a next step, let's put a pin on this side of the design and then start focusing on APIs, both at the CAUSE layer as well as at the Kubernetes layer for minting ACLs and IAM.
Yeah, I think that's the right direction we wanted to go, Saad. Even if it ends up being a secondary KEP to this, I think it's better to put a pin, like you said, in it and flush this out, merge smaller pieces of it than trying to do everything at once.
Right, and it may be that as we figure out the design for that, there may be changes here, but I think this is nicely abstracted by saying, hey, all I want is a secret object. How that secret object comes to be, I don't care. Now, it's the responsibility of a secondary system to create that secret object, and that's the contract between the two.
So I don't, I think, share the opinion that we can sort of take this as it is and do another thing, because I think if we go ahead and remove bucket access and things like that, and because I think some of what's covered by this would fall under the IAM related stuff. And so if you think about literally just wanting to do bucket provisioning, this actually would get quite a bit smaller, this piece. And then bucket access and bucket permissioning would be the next piece that would build off of, it would layer on top of this. But pods wouldn't really access this too much, except for the greenfield case just to create the bucket, but that by itself isn't sufficient, right? All of the using the bucket and accessing the bucket and secrets and credentials and brownfield, all of that then gets pushed to the other problem, I think.
So it sounds like what you're saying is if we scope the problem down to just provisioning a bucket, that means that most of what's proposed here is not necessary, because a lot of it is around how a pod is going to access a bucket, and how a pod is going to access a bucket is way too intertwined with ACLs and IAM to kind of decouple it in this way. Is that right?
I think I want to push
right.
back on that a little bit. And the reason being that IAM is like clearly a separate system from bucket management, but there's two sides to this coin. One is IAM roles, IAM permissions. The other is the ACLs, and the ACLs exist through the storage system and would be handled through storage, like the bucket drivers. And so like in the case of S3, for instance, a bucket policy is a substructure of a bucket. It's similar for GCS and Azure. And the line is blurry now, so that the connection from the user to the bucket could be represented in either system. And so I think we have to take that into consideration here too.
So let me see if I can't see if I can dig at what you're suggesting. And so so one way to look at this is to say, I am effectively going to just manifest the identity that I have in the cluster into an identity that I have in the backend system. So I'm just going to do an identity mapping. Service account X or pod X or whatever is this person on the other end. But that is one part of the problem. Now, it might be that that's all you need because you have defined a global permissions for that particular identity in your backend, such that any bucket that you create, you'd have the appropriate access to. The other model is,
but not only the driver can also act on provisioning, like on binding, because it gets the secret, gets the identity, and the driver can get the identity. We were talking about separating and just passing the identity to the not the secret.
So you're suggesting that it doesn't have to be bucket provision first and then I am layered on. If I tell you who I am at the time that I ask for the bucket to be provisioned, that the bucket provisioner could also create the equivalent of the role binding to the bucket.
Yes, yeah. And in fact, we've implemented this, and it's in use now in like Rook Ceph object, where
I guess the only concern that I have with that model is that works for a greenfield, but doesn't really work for brownfield. Whereas the other model, which is you always layer it on, works in both.
I think
Sorry,
it's
you
sort
were
of
saying
a
that
behavior.
the user existing after the bucket is created doesn't work in brownfield. Is that am I correct?
Not that the user, but the user's access to that particular bucket, right? So I'm suggesting there's two things that get created. There is a user potentially, but for every bucket, you would want to create scoped access for that user to just that bucket. And
right, that's what we
sure,
consider
you
like
could
the,
do that. You could do that at the time you provision the bucket, but in the brownfield case, you don't know who's going to access it, right? Because multiple people, in fact, this whole design is now predicated around the fact that multiple people might be accessing the same bucket, and you don't know who that set of people is, presumably.
right.
When you,
But you
The
watch buckets as well.
So a managed
You can-
brownfield case, like bucket policies are malleable and can be updated after the fact. And I've made sure, like I have accounts in Azure and GCS Online. I've done this after the fact and practiced it out.
right.
You
So
can
I'm
create
saying
a
if you
container and then go and
can
say,
do
hey,
it
take
after
this new container, take this new user, and I've already got the container, make him, give him, read access to this container kind of thing. So after the fact is a commonly implemented way through these services.
right. And so I'm saying after the fact is sufficient. You don't have to do a at the same time. If you have after the fact, you have everything.
Right. Okay. Yeah. Then we're in agreement then. Or rather, I agree with you.
So how could we go about discussing this all these points throughout the week and not waiting for the meeting, so we can actually build material with all these proposals as they develop? Is the mailing list on the 6 storage group a good way to do that?
I think this has gotten to a point where it might make sense to create a dedicated work group and a separate mailing list. But for now, I think it's fine to, use the Kubernetes 6 storage mailing list, use the KEP GitHub.
Okay. Actually, we can actually do issues on GitHub, right? There's a GitHub for where there was a prototypes for Cozy. But if you build a GitHub for Cozy, then we can open issues so everyone can participate and read on the previous discussions without having to do mailing.
That'd be nice. It'd be nice to have some granularity between each topic.
Yeah.
Otherwise,
Yeah.
a mailing list thread could get messy quickly.
Yes. So yeah, if you guys open a GitHub, so we can, I mean, these diagrams, I know they're on the PR for enhancements, but you can move them on that repo, and then we can keep the discussion there and say, well, if we're going off topic on ACLs, let's open an issue for ACLs and discuss it over there. And how we discuss greenfield versus brownfield, etc. Another issue, and just keep the conversation going there, I think.
Yeah, that seems reasonable.
Question is where we want to open the repo. Probably Kubernetes SIGs, but
yeah, that sounds fair. But I don't know who has access to that. And that Kubernetes 6 already has like a bunch of products, and I think Kubernetes 6 also has mostly CSI drivers, right, maintained by Kubernetes team. So because this is an enhancement, and I hope this to be transient at some point. This becomes official, and then we just keep going. And but then where will we keep that going, right? We can also just create issues on Kubernetes 6 main repo. I think there's a repo for that. Let me check that quickly.
okay, I need to hop off for another meeting.
Okay. There's a community repo, so maybe we can use that one. Or
the problem with that would be tracking which issues exist and are applicable here.
Yeah. Else we can just also use enhancements and then just keep track of the issues with a title that says Cozy.
Right, or a Cozy label if we can create that. Or it may be better now if, given that we're having to figure out the permissions, to just start a separate Google group for this. And then we'll have individual threads per topic.
Why don't we
until we can figure out a location.
from this call. If you want to send out notes from the call, John, we can discuss it on the list there in case anyone wasn't able to join today, and then make a decision next week.
That sounds good. Yeah, we'll have
Okay.
that out today.
All right. See you later.
All right.
Bye,
Thanks.
guys.
Thanks.
See you.
Bye.
Thank you.
Thank you. Bye.